So for our topic for today, it's all about additional topics on differential equation of the first order, specifically integrating factors found by inspection. So in here, these are the differentials. These are the exact differentials to keep in mind. So the first one is we have differential of xy is equivalent to x dy plus y dx. And then the second one is we have differential of x over y, which is equivalent to y dx minus x dy all over y squared. And then the third one is we have differential of y over x is equivalent to x dy minus y dx all over x squared. The fourth one is we have here inverse tangent of x over y is equals to y dx minus x dy all over x squared plus y squared. And then the last one is the fifth one, which is inverse tangent of y over x is equivalent to x dy minus y dx all over x squared plus y squared. So in solving integrating factors found by inspection, the main key hint here is this: to pair up all the terms that have the same degree. So to see this, let's try example number 1. So in here, we have example number 1. So we are given that y quantity 2xy plus 1 quantity dx minus x dy is equals to 0. And by the way, we have also an answer here on the right. So the first thing that I'm gonna do is I'll distribute y and dx all throughout these terms. So I'll distribute y and then the dx, and then so we will have 2x y squared dx plus y dx minus x dy is equal to 0. As you can see, this term, we have y dx and then x dy. So if we know that the differential of x over y is equal to y dx and then minus x dy all over y squared. So if I divide both sides of the equation by y squared, so we will have, so dividing both sides of the equation by 1 over y squared, so we will have 2x dx plus, and then quantity y dx minus x dy all over y squared is equal to 0. So this term here, this will become differential of x over y. So by doing that, we will have 2x dx plus differential of x over y is equal to 0. Now, as you can see, we can now integrate both sides. So integrating both sides of the equation, so we will have 2x squared over 2 plus the differential of this, so we will have x over y is equal to c. So as you can see, 2 will cancel out. So we will have x squared plus x over y is equal to c. Multiplying both sides of the equation by y, so we will have x squared y plus x is equals to cy. So that's the answer. So now let's try a more complicated problem. So we are given that y quantity x to the fourth minus y squared quantity dx plus x quantity x to the fourth plus y squared quantity dy is equals to 0. So the first thing that I'm gonna do is I'll distribute y and dx all throughout our equation. So, and then also x on these terms, I'll distribute x also on these terms and also dy on these terms. So by doing that, we're having x to the fourth y dx minus y cubed dx plus x to the fifth dy plus xy squared dy is equal to 0. We know that we have to pair up all the terms that have the same degree. So meaning, we we will group these terms and also these terms. So by doing that, we're going to have x to the fourth y dx plus x to the fifth dy plus quantity xy squared dy minus y cubed dx is equal to 0. And then by grouping this one also, we could factor x to the fourth on this side. So by factoring x to the fourth on this side, we're going to have x to the fourth quantity y dx plus x dy. And then also on these terms, we will factor, by inspection, we could factor y squared, so plus y squared quantity x dy minus y dx is equal to 0. We know that the differential of xy is equivalent to x dy plus y dx. And also, we know that the differential of, what's this? The differential of y over x is equal to x dy minus y dx all over x squared. So, dividing both sides of the equation by x squared, so dividing both sides of the equation by x squared, and also this one, so we're going to have, so x squared will cancel out, so we will only have x squared here. So we will have x squared differential of, so this one is differential of xy plus y squared, and then the differential of y over x is equal to 0. As you can see, we can integrate it. So the next thing that I'm gonna do is I'll divide both sides of the equation by x squared. So by doing that, so we will have x squared, then x squared. So x squared will cancel on this side. So we will have differential of xy plus, so y squared all over x squared. So that's also equivalent to y over x quantity squared, and then differential of y over x is equals to 0. So we don't have a space anymore. So I'll just copy it first. So we're going to have that. We're going to have differential, sorry, we're going to have differential of xy plus y over x squared, and differential of y over x equals to 0. So as you can see, we can now integrate both sides of the equation. By doing that, we're going to have, so integrating both sides of the equation, we're going to have xy plus, so this one we will use power rule. So we will have 1/3 quantity y over x cube, and then is equals to c. So by simplifying our equation, our solution, so we're going to have xy plus 1/3 and then y cube all over x cube is equals to c. And then, so we can also say that by multiplying both sides of the equation by 3x cube, so I will multiply it by 3x cube to simplify our equation. We're going to have 3x to the fourth y plus, so 3x cube will cancel out on this term, so we're going to have y cube is equal to 3, so this is going to be 3c x cube. We know that 3c also is equivalent to c because it is just a constant. So we're going to have c x cube. So that's the answer. Now let's go to our next example. So we are given that y quantity x squared plus y squared minus 1 dx plus x quantity x squared plus y squared plus 1 quantity dy is equals to 0. So the technique here that we're going to use is when there is a consecutive. So in these terms, if you have on both terms, if you have x squared plus y squared, then x squared plus y squared, most of the time, the answer is arctangent. So by doing that, so I'll distribute dx first. So we will have y. This is also the same as y quantity x squared plus y squared, then dx, then distributing dx on this term. So on this term, we're going to have minus dx plus, so distributing, so we're going to have x quantity, x squared plus y squared quantity. So we're going to have dy here. And then distributing plus 1. So we're going to have plus 1 dy is equal to 0. So by pairing up all the terms, so first is, what I'm gonna do is, I'll pair up all the terms. So by the way, I will distribute also y. So I just made a mistake. This is y dx. And this is also distributing x. So we're going to have x. Sorry for my mistake. So we're going to have x dy is equals to 0. Because we will distribute y and then the dx. And then also in here, we're going to distribute x in 1, x multiplied by 1, and then dy multiplied by 1. So we're going to have x dy on this side. So by doing that, by pairing up all the terms, so I'll pair these terms. So I'll rewrite it first. So we're going to have y quantity x squared plus y squared quantity dx plus x quantity x squared plus y squared quantity dy. And then we're going to have plus x dy minus y dx, and then is equal to 0. So by dividing all of our terms by x squared plus y squared, so dividing all of the equation by x squared plus y squared, so we're going to have x squared plus y squared, then x squared plus y squared, and also here, so also on the right side, so this will become just 0. So x squared will cancel out on this term, and then x squared on this term. So we're going to have y dx plus x dy plus, and then quantity x dy minus y dx all over x squared plus y squared equals to 0. So we know that this one is going to be differential of xy. So we're going to have differential of xy plus this one plus quantity x dy minus y dx, oops, y dx all over x squared plus y squared equals to 0. So integrating both sides of the equation, so we will have an answer xy plus arctangent of y over x is equals to c. So that's the answer. So proceeding in our last example, so so I just changed my ink. So we are given that y quantity x cubed plus x y squared minus y dx plus y cubed plus x squared y plus x quantity dy is equals to 0. So the first thing that I'm gonna do is I'll factor x on this side, and then I'll distribute also the dx. So we're going to have so x cubed plus xy squared quantity dx minus y dx plus we're going to have y cubed plus x squared y dy, and then plus x dy is equal to 0. So by pairing up all the terms, we're going to have uh, the, but first I'll factor x on this side, then I'll factor y on this side. So we're going to have x quantity x squared plus y squared dx, and then on this one which will become y quantity y squared plus x squared dy, and then plus x dy minus y dx is equals to 0. So we know that the differential of y over x is equivalent to x dy minus y dx all over x squared. So first is I'll just divide it by we will divide it first by x squared plus y squared. Sorry, we will not use this one. So we will have x squared plus y squared, x squared plus y squared, and then x squared plus y squared. So x squared will cancel out on the first term. So also in the second term, so we're going to have x dx plus y dy plus, so this one, we'll just copy it. So we're going to have x dy minus y dx. So we have quantity all over x squared plus y squared equals to 0. So you can see we can now all integrate both sides of the equation. So integrating all this, so we're going to have 1/2 x squared plus 1/2 y squared plus, so the integral of this one, which is equivalent to arc tangent y over x. So we're going to have arc tangent y over x is equals to c over 2. So by multiplying both sides of the equation by 2, so we're going to have x squared plus y squared, and then plus 2 arc tangent of y over x is equals to c. So that's the answer. So see you on my next video.